Hi guys, good evening everyone. Welcome to the session and welcome once again to the IISC Bangalore previous year question discussion. Yes, we all know that GATE 2024 is going to be conducted by IISC Bangalore and we are discussing the questions that were asked by IISC Bangalore in its previous conducted years. Okay, and those were 2016, 2008 and 2002, and we are looking into the questions of those particular years in subject and sequential manner. And today we are going to look into EMFT. So earlier I have covered, in this particular series I have covered digital circuits, Ashu sir has covered control systems, Sanjay Rathi sir has covered network theory, and today we'll cover up electromagnetic field theory. The electromagnetic field theory, and of course the contents that we are going to cover today the contents we are going to cover up today in the electromagnetic field theory will be those contents which are common to EC and EE. Okay, and then in the next session I will cover up exclusive EC topics like waveguides, antenna, transmission line, wave propagation. Okay, that will be covered separately for EC, but all the topics, the questions which are related with fundamentals of vectors or electrostatics, magnetostatics, the time varying field basic concepts, Faraday's law, and etc. That is what we will cover up today. Okay, corresponding to the years of IISC Bangalore 2002, 8 and 16, right? So let's get started. Okay, and yeah, you can, like I shared you the entire PDF of digital complete IISC previous year questions along with solution. So today's PDF also I'm going to share you, okay, the complete questions along with the solutions, whatever we discussed today. Okay, you can join it in, you can find it in my Telegram group, and also to get more concepts and latest notifications about exams and upcoming vacancies. Okay, for doubt discussions, for all other activities, you can join the Telegram group. The name is as mentioned here. Okay, and quickly also share the session to your friends, and this is a brief intro about me. It's a regular one, Okay, now guys, UPSC ESE 2023 mails results have been out, and just today even the interview dates have been announced. Okay, if you are one of them looking to get free mock interview guidance, okay, with a panel very similar to what is like a UPSC ESE panel, you can join. Okay, you can just share your result and we'll provide you the free mock interview guidance and the support for all interview related preparation. Okay, so the link, okay, to share your result is in the description. Okay, so now guys, let's get started with the questions very quickly. Here it is. Okay, 2002 EE 1 marks. I have mentioned the year, I have mentioned the branch, and I have mentioned the marks for that particular question. The marks for that particular question. Okay, so come on, answer this one quickly. Yeah, chalo. So guys, let's get started. So given vector field F divergence theorem, so sometimes, okay, sometimes even in these dates, not like 2002, sometimes even in these dates, some fundamental theorem, some statement based questions can also be expected. Okay, so like, okay, the divergence theorem. What divergence theorem? Of course, the Gauss divergence theorem, which says that the surface integral of a vector function F over a closed surface is equal to volume integral of the divergence of F. Volume integral of the divergence of F, option number A, and it should be definitely closed surface. Okay, but there is only one option matching up, but definitely it should be clearly specified that it should be a closed surface. Okay, it should be a closed surface because the Gauss divergence theorem is applicable for closed surface. So integral F dot ds is given by the surface integral F dot ds is given by del dot F, that is the divergence of F, the volume integral of divergence of F, right? Next one. Okay, so GATE 16 EE 1 mark. In cylindrical coordinate system, the potential produced by a uniform ring charge is given by FRZ, where F is a continuous function of R and Z. Okay, let E be the resulting. Now see, from the potential, how do you calculate E? E is given by negative of the gradient of V, because V is only a function of space. Okay, V is only a function of space. Okay, what is V given to you? Okay, right now, what is E or V that is given to you? It is only a function of space. Okay, independent of time given. Ultimately, it is not time varying, it is independent of time. And for the static fields, what do we call it as static fields? For static field, the curl of the electric, in static situations, the electrostatic field is a conservative field and del cross E is given as 0. Del cross E is 0 for static fields. for the static fields, for the fundamental Maxwell's equation, del cross E is 0 for the static fields. Del cross E is 0 for the static field. So correct answer is gonna be option number B. Okay, next one. For static electric and magnetic fields in an, okay, again mentioned, static electric and magnetic fields in an inhomogeneous source-free medium, which of the following represents the correct form of 2 of the Maxwell's equation? Okay, so as I just told you, for static electric field, del cross E is equal to 0. And also with respect to B, we have divergence of B equal to 0 because of the absence of magnetic monopoles. This is known as the conservativeness of electrostatic field, and this is due to the absence of magnetic monopoles. We get the result del dot B is equal to 0. So option number D, del dot B equal to 0. GATE 2008 EC 1 marks. Previous one was 2016 EE 1 mark. So I've mentioned year, branch and the marks for that particular question. Okay, let's move ahead to the next. Okay, some fundamental questions put in the beginning. Yeah, next one. This is again a fundamental one only. 2002 EC 2 marks. The electric field on the surface of a perfect conductor is 2 volt per meter. The conductor is immersed in water with epsilon equal to epsilon naught. The surface charge density on the conductor. Okay, so say this is a conducting surface. Okay, we should know that. Okay, on the surface of a conductor, especially on a perfect conductor, electric field is always normal to the conductor. Okay, the electric field is always normal to the conductor. Electric field means only the normal component. Electric field is only normal to the conductor, and that is given by what formula? That is given by the formula rho s, that is the surface charge density divided by epsilon A n cap. Okay, so here I think they are only concerned about the magnitude. Okay, electric field magnitude is given to you. Okay, so what is the magnitude of electric field given to you? 2, that is equal to rho s divided by epsilon, and epsilon will be epsilon r epsilon naught. So we can get the surface charge density rho s. Rho s is known as what? Rho s is known as the surface charge density. So that is 2 into epsilon r. Okay, achha, directly epsilon is given to you, that is 80 epsilon naught. Okay, so it is 160 epsilon naught. Epsilon naught का value put कर देंगे, that is 8.854 into 10 raised to the power minus 12 coulomb per meter square will be the units. Okay, so ultimately let me just solve the calculation and return you the answer. Just a moment here. Just a second, Hannah. Yeah. So what is the calculation I need to complete? 160, that is into 8.854. Okay, so 1416. So it will come approximately to 1.41. 1416, 10 power minus 12. So 1000 multiplied by 10 power minus 12, 10 power minus 9 में आ जाएगा. 10 power minus 9 coulomb per square meter. Coulomb per square meter. Option number D. Simple. Okay, option number D it is. Right? Okay. So let's move ahead to the next then. Okay, concentric spherical shells of radii 2, 4 and 8 meter carry uniform surface charge densities. Okay, 20 nanocoulomb per meter square, minus 4 nanocoulomb per meter square and rho s respectively. What is the value of rho s required to ensure that the electric flux D equal to 0 at the radius 10 based on Gauss law? Okay, based on the Gauss law. The fundamental statement of Gauss law, which says that the flux crossing any closed surface, okay, is equal to the charge enclosed by that surface. The flux crossing any closed surface is given by the total charge enclosed by the surface. Is given by the total charge enclosed by the surface. Yes, Vikram, correct answer for the previous one. Okay, now you have concentric spherical shells of radii 2, 4 and 8. Now let's assume it to be looking like, let's draw this spherical shells as a circular front only right now, and you have 3 radii 2, 4 and 8. Yeah, maybe let's do it the spherical way only. Okay, and what is the required to ensure that electric flux density D should be equal to 0 at the radius 10? Okay, at the radius 10. Acha, by the way, if you talk about this D is what? D is the electric flux density. Okay, D is the electric flux density, that is flux per unit surface area. Okay, area for radius 10 meter, but this should be 0, so we don't need that area. We can simply say that the xi equal to 0, and xi as per the Gauss law should be equal to the charge enclosed. Okay, so you have first of all 3 spherical shells, 2, 4 and 8 meter, of 2, 4 and the 8 meter. Okay, one is for 2 meter, one is for the 4 meter and one is for the 8 meter, correct? 2, 4 and 8. Right, and now let me draw the Gaussian surface. Okay, a Gaussian surface is required to be what? It is required to be a closed surface. Okay, so what is this? This is my Gaussian surface, a spherical surface with the radius of 10, and over any Gaussian surface I can apply xi equal to q enclosed, and there are three spherical shells. Okay, let's say this has the surface density rho1, this has the surface density rho2, this has the density rho1, this has the density rho2, this has the density rho3, which is rho s. Okay, now what are the values of rho1 and rho2? 20 and -4 बाद में put कर देंगे. Okay, we'll put it out later. Okay, and the radii also given to you. This radius is equal to 2 meter. Radius बाद में use करेंगे. Okay, now the surface densities are given. Okay, so now let us apply. If I start applying xi equal to q enclosed must be 0. Now what is the q enclosed? That is going to be q1 plus q2 plus q3, and that net sum is going to be 0. Okay, because there are total 3 charges within it. So direct charge is not given, charge density is given. Okay, so what is the first charge density? Rho1. Okay, rho1, that is the charge density, charge per unit area. So what is the total charge? Charge density into the area. Okay, so what is the area of the first sphere? And that is given by 4 pi r1 square. Next is going to be rho2, similarly multiplied by area, 4 pi r2 square. Next is going to be rho3 multiplied by 4 pi r3 square. This net sum should be equal to 0. So 4 pi is nothing but common. And what is the value of the rho1? Okay, first density is 20 nanocoulomb per meter square and radius is 2. Okay, 20 nanocoulomb per meter square and radius is 2. So it is 2 square. Okay, it is 2 square. Okay, so 10 power minus 9 will definitely come up here. Nanocoulomb hai na, so 20 into 10 power minus 9 into 2 square. Next surface charge density is minus 4. Okay, minus 4 nanocoulomb per meter square into the radius, that is 4. Next radius is 4. Okay, plus rho3, which is rho s, that is the unknown value, into r3, and r3 is 8 square, and the net sum is 0. So 4 pi you can divide there, 0 by 4 pi will be 0. Good evening, dreamer. Okay, so now I just need to do these calculations. I have 20 square, 2 square, 4 2 is 8, 80, and this is minus of 64 into 10 raised to the power minus 9. This I will send on the other side, so minus laga denge, and then I have 64 rho s on the left hand side. So now I have got my answer. What is the value of rho s? Dear, minus 16. Okay, minus 16 divided by 64, that is minus 1 by 4, 10 raised to the power minus 9, or I can say minus 0.25, and 10 power minus 9 will convert to nano, and the unit of density is nanocoulomb per square meter. Minus 0.25 nanocoulomb per square meter. Okay, and they're asking the answer in nanocoulomb per square meter. So numerical type answer that is to be entered should be minus 0.25. Should be the minus 0.25. Okay, now it depends. Sometimes the questions are simple for 2 mark. This is also simple. Okay, but some questions can like little bit of time. Okay, for 1 mark. Okay, it's a EC 2016 1 mark IISc Bangalore question. Little bit time, not very much time, but as compared to a 1 mark question, it took normally more time as compared to a 1 mark level. Okay, but the question is simple, concept is simple. It is directly a Gauss law question. It is directly a Gauss law question. Okay, चलते हैं next question की तरफ. So 2 electrodes, very simple. GATE 2016 EE. There were lots of fundamental questions in EE also in 2016. So 2 electrodes whose cross-sectional view is as shown in the figure below are at the same potential. The maximum electric field will be at the point. Okay, so now, okay, all the 4 points are given on the number 1 electrode, and you must be able to see, conceptual question hai, ki the point C is closest to the other electrode. Okay, the point C is closest to the other electrode, and we know that the electric field is inversely proportional to the distance. Okay, the electric field is inversely proportional to distance, proportional to 1 by r. Okay, for any type of distribution, it is always proportional to 1 by r, and C is the closest point, that is, it has the smallest distance, so we can expect the maximum field at the point C, and let me mark the option number C, that's it. Okay, sometimes questions are purely logical. Okay, just they need to check your approach and basic understanding. The approach and the basic understanding. Okay, so option number C is very correct. Moving ahead to the next question here. Okay, so 2 electric charges Q and minus 2Q are located at 0, 0 and 6, 0 on the xy plane. Okay, it's simple xy plane. What is the equation of zero equipotential curve? Now, first of all, what is equipotential curve? We know equipotential curve is a curve at which potential is equal throughout. At which the potential is equal throughout. And what is that equal potential I want? I want the equal potential to be 0. I want a zero equipotential curve. I want a zero equipotential curve. Okay? Okay, so zero equipotential curve is a curve in which V equal to 0 throughout the curve. V equal to 0 throughout the curve. Acha ji, theek hai. Now what is that curve we need to find? What is the equation of that curve? Okay, so now let me draw the diagram. Two charges are located at 0, 0 and 6, 0. So let us start by sketching it, the problem. Okay, so here it is. One of the charge 0, 0, another one, suppose 6, 0. Okay, suppose this is 0, 0 and the charge is Q. This is 6, 0 and the charge is minus Q. And let's take any point P on the curve. Let's suppose P is any point on the curve. At the distance R1 and R2 from the two charges, and sorry, this particular charge was minus 2Q, correct? This was minus 2Q. Okay, what is the point P? Point P is any point on the curve. Which curve? Wahi to nikalna hai. Okay, that equipotential curve which we are required to find. Suppose P is any point on the curve, and because it's a two-dimensional plane, let me write down the point as x, y. Let me write down the point as x, y. What is the total potential at the point P, dear? What should be the total potential at point P? Okay, we can apply the superposition, and potential being a scalar quantity, we need to just add the magnitude V1 plus V2. V1 is the potential due to the charge Q. V2 will be the potential due to the charge minus 2. And what is the potential due to point charge? Very simple formula, KQ by R. Right, K, first charge is Q divided by distance R1. Okay, plus K, and next charge is minus 2Q. K into minus 2Q divided by R2. This total should be 0. This total should be the 0. KQ by R1 and K minus 2Q by R1. Clear, everybody? Okay, and this should be equal to 0. That means I can take out the potential at the point P. K common. K is what? Waise not needed, but K is 1 upon 4 pi epsilon naught. Okay, into Q by R1. Acha, Q also can be taken common. KQ. K को ले लिया common. Q upon R1 minus 2Q by R2 should be equal to 0. Okay, Q भी outside ले लिया, तो 1 upon R1 will be equal to 2 upon R2. Right? So you have R2 equal to 2R1. This will give you the equation. R2 is equal to 2R1. Acha, we can take the square directly, because to calculate R1, R2, we were going to apply the distance formula. So better you can take up the square. So R2 square is equal to how much? Is equal to the 4R1 square. The R2 square can be written as 4R1 square. Okay. Now, what is the R2 square? Distance formula. Distance between x, y and 6, 0. So distance formula say it's going to be x minus 6 whole square plus y minus 0 whole square. This is going to be 4 times R1 square. R1. Okay, distance between xy and 0, 0. That is simply x square plus y square. Distance square, R1 square I am writing. Okay, we just have to simplify and arrange this. So I have x square plus 36, a square by plus b square minus 2ab, then plus y square is 4x square plus 4y square. Okay, so solving it, x square y square एक बार cancel किया. Rearranging, I have 3x square plus 3y square. Shifting 12x on the other side. Plus of 12x, okay, should be equal to 36. Cancel by 3. Cancel by the 3. Just a moment, okay. So if I cancel by the 3, I have the x square plus y square dividing by 3 plus 4x is equal to 12. Okay, so x square plus 4x. Plus 4x. Now, if you add 4, it will make a square. Plus y square equal to, add 4 on both the sides, 12 plus 4. So now I have x plus 2 whole square plus y square is equal to 16, equation of a circle. Okay, it is given by the x plus 2 whole square plus y square is equal to 16, the equation of a circle, okay, whose center will be minus 2 comma 0 and radii equal to 4. Okay, that means with some center minus 2 comma 0 and radius equal to 4, there will be a circle. Okay, there will be a circle. Okay, such that there will be a circle such that, इसको थोड़ा सा मैं राइट करके लिख देता हूँ. Okay, with the center, okay, that is at minus 2 comma 0. Suppose this is minus 2 0 and radius 4. randomly मैं draw करता हूँ. With the center at minus 2 comma 0 and some radius that is 4, okay, there will be a circle, and when you pick up any point on the circle, of course the circle will be passing through point P. I have taken point P there, चलो point P से pass करा देते हैं. ठीक है, rough diagram है ना, don't mind the drawing, it is just a rough diagram. Okay, with radius equal to 4 and the center minus 2 comma 0, there will be a circle such that all the points on the circle, all the points lying on the circle, okay, will have zero potential, and that is what is zero equipotential curve. This is your zero equipotential curve. This is known as your zero equipotential curve. Zero equipotential curve. ठीक है. Moving ahead to the next question. Consider the charge profile shown in the figure rho, that is the charge density. Okay, what is the resultant potential distribution? Okay, the relation between potential and volume charge density. The relation between the potential and volume charge density is given by GATE EC 2 marks question. This is a good question. Is given by the Poisson's equation. Okay, and the Poisson's equation which says that del square V is equal to minus rho V by epsilon, right? No, Rahul, nothing like that. Nothing like that. It can be anything. Okay. So totally, because you know questions are sent by all IITs. It is not only IISC Bangalore setting it. So del square V is equal to minus rho V by epsilon. ठीक है, minus rho V by epsilon. Now let's consider for x greater than for x positive. If I take the, and these are the options which is described by what options are there on the next slide. Okay, so if you look into this, yeah, so del square V is equal to minus rho V, minus rho by epsilon. So if you take x greater than 0, okay, for x greater than 0, it is constant, that is equal to at rho 1, that is constant, that is equal to rho 1. So what is going to be del square V? Okay, actually 0 less than x less than a. Okay, what is going to be the del square V? Del square V is minus rho 1 by epsilon. It is going to be minus rho 1 by epsilon, and rho 1 is clearly flat, it is constant. It is clearly flat, it is constant. Okay, so now because it is constant, okay, what is going to be del of V? Okay, what is going to be del of V? Answer, it is clearly a function of x. It is clearly a function of x. Okay, V is nothing but clearly function of x, and because it is function of x, what will be the Laplacian equal to? It is sum of all second derivatives with respect to x and y and z. Okay, but because it is only a function of x, you can write down del 2v by del x square is equal to minus rho by epsilon. So let us solve it in that format only. It becomes a differential equation case. Del 2v by del x square is equal to minus rho 1 by epsilon. Okay, second derivative. So if you integrate once, you get del v by del x. And what is going to be del v by del x? Minus rho 1 by epsilon into x. Minus rho 1 by epsilon into x. It's like kx. Okay, this is constant. So integration of k is kx. Okay, now what is going to be v then? Achha, plus some constant of integration, suppose c1. Okay, now when you again integrate, okay, to again eliminate the derivative, minus rho by epsilon, x ka integral x square by 2, so minus rho 1 by 2 epsilon x square plus c1 integral c1x plus another constant of integral c2. Okay, so this looks like a parabola going downwards. Okay, parabola opening down. Very clear? This represents a parabola opening down. Now to calculate the value of C1, C2, some other conditions will be given. Okay, but okay, that's not required right now. So it has to be a parabola opening down. Okay, it has to be a parabola opening down, and also for the other side. Okay, for the other side, that is b is less than x is less than 0. Okay, for this particular side, you will have del 2v by del x square is equal to, okay, what is the value of rho here? That is rho 2. Okay, that is actually rho 2, that is negative. Okay, that is negative. Okay, this should be actually written as minus rho 2. Hai na? This should be actually written as minus rho 2. So if I put down minus rho 2, I am going to get plus rho 2 by epsilon. Minus rho by epsilon, minus minus cancel. Okay, minus minus cancel. Okay. Now, okay, what is del v? Now similarly, doing the integral twice. Okay, what is v? Okay, this time it is going to be rho 2 by 2 epsilon x square plus some constant, suppose c3x plus c4 plus c4. Okay, rho 2 by 2 epsilon x square plus c3x plus c4. Is that okay? That is what is going to be the potential. Okay, that means this is a parabola opening down. This is going to be the equation of the parabola opening down. Sorry, opening up. Parabola opening up. Okay, because it is plus x square. Okay, so for the left hand side, this one is, I suppose, left hand side, parabola opening up, right hand side, parabola opening down. Okay, the face should be down. Okay, and that is evident in the option number C. This is the parabola opening. Now, if you complete it, it is opening up. Okay, but it is only up to the B, and right side it is only up to the A. Correct answer is option number D. Acha, then why not maybe the others? Okay, ye bhi dekhte hain. If you put down, okay, yeah, definitely, if you put down the potential at x equal to 0, let me check up. Yeah, the potential has to be continuous because there is a discontinuity at the charge profile. Yes. And yeah, when you put down x equal to 0, potential is constant, and that is going to match because some additional data when I take out. Okay, but that is not required actually, only options will be matched. So potential has to be matched at origin, and the potential has to be continuous at origin. Okay, that is why it has to be D. Okay, it has to be D or A. And also guys, dekho, after A, look into this, after A the charge, the rho is 0. Okay, rho equal to 0 means del 2v by del x square equal to 0. That doesn't mean that v will be 0. V can be some constant or linear curve. Again, some additional data is required, but del 2v by del x square equal to 0, we can't say that potential will be 0. We can't say that potential will be 0. So that is why D is the most suited option. D is the most suited option that I have put up here. Okay, ji? D is the most suited option. Next question. Okay, gate 16 EC 2 marks. Okay, take a gate EC 2 marks. Don't listen to such rumors, Rahul. Okay, don't listen to such rumors. There are people who are not preparing and they want to spoil the preparation of the students who are preparing. Okay, don't bother about that. Just be consistent in your preparation. The parallel plate capacitor shown in the figure has movable plates. All right, the capacitor is charged so that the energy stored in it is E. Okay, when the plate separation is D. The capacitor is then isolated electrically. The capacitor is then isolated electrically and the plates are moved such that the separation becomes 2D. Okay. At this new plate separation, what is the energy stored? Acha, what is the general formula for the energy stored? Okay, the electrostatic energy stored, normally we write it as half CV square, or it is also given by Q square by 2C, because we know Q equal to CV for the capacitor. Okay. Right. Now it is isolated electrically. So when you isolate it electrically, there cannot be any charge, okay, increased or decreased. That means Q remains to be same. Okay, that means Q remains to be same. Acha, as I told you, it is Q square by 2C. Let's take up this formula because Q is going to be same. So I prefer the formula involving the charge Q, and if it is Q square by 2C, acha, parallel plate capacitor, what is the capacitance? Epsilon S divided by D. Epsilon being the permittivity, S being the surface area, and D being the separation between the plates. So this going to become Q square D is divided by 2 epsilon S. Okay, 2 epsilon S. Okay, now what is going to be WE1? Okay, it is Q square D by 2 epsilon S, but what is going to be WE2? Okay, that is Q square, only what is changed is D, because isolated electrically means Okay, the charge under both the conditions will remain same. Q1 equal to Q2. Suppose both are equal to Q. Both are equal to Q, right? So but plate separation is doubled, divided by 2 epsilon s. Rest everything is same. Same plates are there. That means the area is same. Only the separation, they are moved away. It has movable plates. Okay, the plates are moved away. Okay, now this energy they called it as E. Okay, this energy they called it as E. Okay, the capacitor is charged so that the energy stored in it E when the plate separation is D. So when the plate separation, clearly you see, when the plate separation becomes 2D, the energy also becomes 2E. It is directly proportional to the plate separation if the charge is constant, and if the plate separation is doubled, the electrostatic energy stored within the capacitor system is also doubled. Option number A, 2E. Option number A, 2E. 2016 EC 2 marks, conceptual, more or less like conceptual question. Yes, Rajesh, very well said, and it is always 100% true. We also, keep on guiding you about just be prepared fully and be confident about your concepts. Any type of paper can be handled. Next question, right, again based on a capacitor, 2008, EE2 marks question. Okay, a capacitor consists of 2 metal plates, each 500 cross 500 mm square and spaced 6 mm apart. Okay, the space between the metal plates is filled with a glass plate of 4 mm thickness and a layer of paper 2 mm thickness. The relative permittivity, understand it is a typo error here. Okay, the relative permittivities of the glass and paper are 8 and 2 respectively. Neglecting the fringing effect, the capacitance of the system will be. Okay, so there are 2 metal plates 6 mm apart, but the space is filled with glass up to 4 mm and a layer of paper of 2 mm thickness. Okay, layer of paper of 2 mm thickness. Okay, it is 100% there, Ravi Teja. It is 100% there in the syllabus. Okay, because without that you can't directly come to the Maxwell's equation. Okay, and even recently you will find the questions also similar related to it. Okay. So you have 2 plates. Now let's understand this given configuration and the given arrangement of the capacitor. You have 2 plates which are initially 6 mm apart. They are the 2 plates which are 6 mm apart, right Aji? 6 mm apart, and they have the plate area, suppose S, and that is how much? The plate area is 500 cross 500 mm square. Okay ji, and they are spaced 6 mm, but the space between them is filled with glass up to 4 mm and paper up to 2 mm. Okay, okay, this is 4 mm and this is the remaining 2 mm. Up to this 4 mm, for a thickness of 4 mm there is glass having the permittivity of 8, relative permittivity of 8, and for the remaining 2 mm it is the paper, and that is having the relative permittivity of 2. Okay, this is what is given. Okay, now we know that C is epsilon S by D. Epsilon S by D. Okay, plate are common, that means plate area is same, but epsilon, there are 2 different materials, so different epsilons are there. Okay, and also the thickness of glass and paper is different, so the D, the separation between these 2 plates and these 2 plates is different. Okay, that means both of them will have different capacitance, but although they have different capacitance, how is the picture coming up? It is the case of what? It is clearly the case of series capacitance. It is clearly the case of series capacitance. Suppose this is C1, this is C2. So what is going to be the C equivalent? For series capacitance, you know the formula, na? C1 C2 upon C1 plus C2. This is the equivalent capacitance formula for series capacitance. Okay. So plate separation. Chalo, plate separation, if I simplify, this is 5, 5, 25 and 10 power 4 multiplied by mm square. So mm square, 1 mm is 10 power minus 3. So mm square 10 power minus 6. So 10 power minus 2 is left. So 0.25 in terms of SI units, meter square 0.25. Okay. Now what is individually C1, C2? C1, epsilon 1 S divided by D1. What is going to be C2? Epsilon 2 S divided by D2. Acha, values. Epsilon 1. Epsilon is epsilon or epsilon naught. The first one is 8. So 8 epsilon naught into 0.25. That is the plate area divided by the separation. Separation is 4 mm. right? 4 into 10 raised to the power minus 3, and this becomes 8 into 0.25, 2. Okay, 2 by 4, half into 1000, 500. So this one is 500 epsilon naught last में put करते हैं. Another one, the next permittivity is 2. So epsilon is 2 epsilon naught multiplied by the same plate area 0.25 divided by the plate separation, okay, which is 2 mm this time, 2 into 10 power minus 3. So this is how much to cancel? 0.25, 1000 into 0.25, 250. This is going to be 250 epsilon naught. This is going to be 250 epsilon naught. Okay. So what is the equivalent capacitance? As I told you, C1 C2 upon C1 plus C2. Okay, so that is 500 epsilon naught multiplied by 250 epsilon naught divided by addition of them 750 epsilon naught cancel, 250 by 753. The answer is 500 divided by 3 epsilon naught, or it should be 500 divided by 3 into epsilon naught, 8.854. 10 raised to the power minus 9. So let me just calculate this number. Turns out to be 1475.67. 1475.67, 10 power minus 9, which will become nano, and capacitance is in farad. So 1475.67 nanofarad. 1475.67, so approximately B. 1475 nano picofarad. Oh, sorry. Why did I write 10 power minus 9? No, I'm so sorry. Yeah. So that is a correction. Epsilon naught we know is 8.854, 10 raised to the power minus 9. So this becomes picofarad. Okay? This is 10 power minus 12. Yeah. So 1475 approximately picofarad is the final answer. 1475 picofarad is the answer. Done hai ji? Okay ji. Next question. A parallel plate capacitor, okay, filled with 2 dielectrics is shown in the figure below. If the electric field in the region A is 4 kilovolt per centimeter, what is the electric field in the region B? Tell me. What is the electric field in the region B? Okay. A parallel plate capacitor filled with 2 dielectrics, okay, the 2 different permittivities given is as shown below. Now dhyan dena. Okay. Looking into the picture, what you can tell is, of course, different dielectric, okay, different permittivity means different value of the capacitance. Also, look into this. If you talk about the first zone, let me clearly make a boundary. Okay, so even assume, let's say both the regions are equally distributed. So the plate separation, this will be total S by 2, and this is going to be S by 2. Okay, and the separation between them is okay, common, but epsilon is different. And also guys, this is a parallel arrangement. Why? Because voltage at both the ends, you know, if you calculate the voltage difference at these 2 plates, and if you calculate the voltage difference of these 2 plates, it is same. Okay, because the plates are common actually. So what it is the case of parallel capacitance. This one is the case of parallel capacitance. You have the capacitance C1 connected in parallel with the capacitance this is C1, this is C2, okay, and both are connected in parallel. Okay. Acha, now they are asking what is the electric field in region B. Okay, now for any parallel plate capacitor, very simple thing about the parallel plate capacitor. Okay, for any parallel plate capacitor, electric field is simply given by V by D. Okay, so what is the electric field E1? देखो, हम ये बोल सकते हैं, because of the parallel arrangement, V1 is equal to V2. Okay, let's say this is V1, let's say this is V2. Okay, so V1 is equal to V2 because of the parallel arrangement. Also, D1 is equal to D2. Separation same है ना, 2 centimeter. Okay, so using this, we can say that E1 will be E2. The electric field in both the regions will be same only. So what is the electric field in the region A? 4 kilovolt per centimeter. Same will be in the region B. Okay, so both of them will be 4 kilovolt per centimeter. 4 kilovolt per centimeter. Okay. So again, see, it's a 2016 EE 1 mark question. So around capacitor, some conceptual questions are there, which are not much. Okay, previous one was just calculative, but before that, if you talk about that plate separation, that was conceptual. Ye calculative tha. Okay, but again 2016, if you come back, it is again a conceptual, okay, basic understanding of the parallel plate capacitor. It is going to be 4. E is equal to V by D. Okay, separation between both the plates are same and both of them are connected in parallel. So V1 and V2 are same, D1, D2 are same. That is why electric field E1 and E2 in both the regions will be same. Answer will be 4 kilovolt per centimeter. Answer will be what? Answer will be the 4 kilovolt per centimeter. Next one. A positive charge Q is placed at x equal to 0 between two infinite metal plates placed at x equal to minus d and x equal to plus d respectively. Okay, the metal plates lie in the YZ plane. The charge is at rest at t equal to 0 when the voltage plus V is applied to the plate at minus d. Okay, and the voltage minus V is applied to the plate at x equal to plus d. Okay, assume that the quantity of the charge Q is small enough that it does not perturb the field set up by the metal plates. Okay, what is the time that the charge Q takes to reach to the right plate? Acha. The charge is set into motion. Okay, the charge is set into the motion. Okay, it has some kinetic energy. Okay, and that should be equivalent to what? Law of conservation of energy if I apply. Okay, it should be equal to the work done in moving the particular charge. Okay, and what is the work done in moving? Work done per unit charge is known as the potential. Okay, so what is the work done in moving the charge? Okay, see, if I talk about, let's say this is the work done, and the kinetic energy we know is given by half mv square, and the work done is given by q into v, where it is clearly mentioned that the potential plus v is applied to the plate at minus d, minus v is applied here. Okay, so what is the potential difference here? It's going to be v only, because this is exactly at center, I can say. Okay, right. What is the potential difference here? It is v. It is equal to the v. Correct. Okay, yeah, that is correct. Now, what is the velocity? Yeah, let's not confuse v and u. Let's call it as mu. Okay, this is half mu square. So what is going to be its velocity? It can be written as 2qv divided by m under root of this. Okay, now we need the time. Time is given by distance upon speed. Okay, distance upon speed. Okay, and distance is d. Okay, distance, this is minus d, this is plus d. So here distance is only d, x equal to 0 to x equal to d. The distance traveled is d only. Okay, so d by u. Okay, and taking the reciprocal of u, it becomes d root m divided by 2qv. Now what they are asking is, the time that it takes is proportional to what? In terms of d and v, it is proportional to what? In terms of d and v, it is proportional to what? Okay, that the time is proportional to the d divided by under root of v. D divided by under root of v, correct? D upon root v. So it should be option number C. It's a good question. Okay, so there is a particular work done by the presence of electric field to move the charge. The work done in the presence of electric field is given by Q into V. Okay, V being the potential. Okay, and because of that work done, the charge is set into motion. If it is into motion, it has some kinetic energy, and that is given by half mv square or half mu square, the kinetic energy formula. With that, I am able to relate the speed formula, and then time is distance by speed. To reach to the right plate, it travels a distance d. Okay, to reach to the right plate, the distance that it travels is d. Okay, chalo, that's it. Chalo, done. Moving ahead to the next question, dear. Yeah, before I take up the next question, some quick updates for you that this coming Sunday, that is 3rd September, just day after tomorrow, okay, you have the chance to win up to 90% scholarship by appearing in the BYJU'S National Scholarship Test. Yes, you can take a next step towards success in GATE. Okay, but yeah, if you really want to prepare for GATE under the best faculty team, but are concerned about your financials and, you know, want some discount, some benefits, so you have to just prove yourself. Okay, and you can get, based on your performance, based on your caliber, you can get up to 90% of the scholarship. You can register now on the BYJU'S exam prep app. Also guys, okay, do you want to target 13 out of 13? And it is achievable. Maths, it is achievable. That is why we say 13 out of 13. Okay, but how do you score it? What are the techniques? What are the tricks? What are the tips to score the maximum, that is 13 out of 13 in engineering mathematics? Okay, attend is free. Make a live interactive workshop with me again on the BYJU'S exam prep app, and this is going to be live on 6th September. That is nothing but Wednesday at 7:30 p.m. Okay, at 7:30 p.m. You can register now. Okay, you can register now for free and you can join me live Wednesday 7:30 p.m. Okay, next question guys. Gate 16 EC 1 mark, again a conceptual question. A uniform and constant magnetic field B equal to Bz, that is in the Z direction, exists in the Z direction in vacuum. A particle of mass m with a small charge q is introduced into this region with initial velocity Vxx plus Vzz. Given that B, M, Q, Vx, Vz are all non-zero, which one of the following describes the eventual trajectory of the particle? Eventual trajectory of the particle. So the magnetic field B is actually Bz. Yeah, let me write it as Baz cap, and the velocity of the particle, okay, the velocity of the particle is given by Vxx cap, that is Vxax plus Vzaz. Okay, the hint is there is a component of velocity. There is a component of velocity, okay, in the x direction that is perpendicular to B. There is a component of velocity, okay, in the z direction, and in the z direction magnetic field also exists. Okay, this one, okay, is towards B, or you can say parallel to the field. Okay, whenever particle moves in the direction parallel to the magnetic field, these are some straight concepts and results you must know. Everything you can't derive, at least for a 1 marker level question, but you have to combine some standard results. Yes, whenever a particle moves with a velocity parallel to the B field, it will always be moving in a linear direction. Okay, right, because the force is given by what? The force is given by Q into V cross B, right? If they are in the same direction, Fm is equal to 0. If they are in the same direction, V cross B is 0, Fm is equal to 0. Okay, right? So net force is 0 and it moves in the linear direction. No, F is mass into acceleration. Acceleration is dV by dt. By that we draw out these trajectories. Okay, but these are standard results. And if it is perpendicular to the B field, then it travels in a circular path. Now there is one component of the velocity, okay, that is going to, okay, if suppose only this was the velocity, then the particle is moving constantly in a circular direction. But dear, there is one more component which is trying to pull the particle in the linear path. Okay, so one component circular, another one tries to move it forward along a linear path. So what is the eventual trajectory? Linear भी चलना है, circular भी चलना है. Okay, so what is the eventual trajectory? It ultimately appears like a helical path. So the particle moving in a helical motion. Why in the z direction? Because, okay, the component of the particle, the velocity which is parallel to the B field is in the z direction. Okay, so in the z direction it follows the linear path. Okay. And then because of the circular path there are circle traces. So ultimately it's a helical path but looking along in the z direction. This is what it is. Clear everybody? So it's again a conceptual question. It's again a conceptual understanding question. Next one. The current density in a medium is given to you. J is equal to 400 sin theta by 2 pi r square plus 4 ar ampere per square meter. Okay, the total current and the average current density flowing through a portion of the spherical surface given to you are given by. Now, how do you calculate the total current? It is integral J dot ds. It is nothing but integral J dot ds. J is in the radial direction, AR direction. So, what is the ds? Along AR direction, the ds is given by, okay, spherical coordinates knowledge, r square sin theta d theta d phi ar. R square sin theta d phi ar. Okay, so you just have to take it's a surface integral question. You just need to solve it up. Right. Chalo, just quickly solve it up. Just allow me 1 minute as well. Okay, so let me see if some calculations are done. This is the formula hint that I have already given to you. Okay, so let me write down again I, that is integral of j dot ds. Let me put down the values. So j is equal to 400 sine theta upon 2 pi r square plus 4, right? Correct. Okay, that is in the AR direction. That is why I take the ds which is in the r direction, and that is given by r square sine theta d theta d phi AR. Okay, and since it is d theta d phi, let's put it as a double integral case. Okay. Okay. Now AR dot AR is 1, of course, and whatever are the constants, let me push it outside. 400, and even r is constant because okay, you are calculating on a portion of spherical surface for which r is fixed, that is 0.8. Okay, r is equal to fix 0.8 meter. Okay, so the current will be 400, okay, r square, that is 0.8 square divided by 2 pi into 0.8 square plus 4. Okay, plus 4. Okay, and then you are left with the integral sine theta. It's going to become sine square theta. So let's integrate them separately now, because it is a variable separable case with both the limits constant. Sine square theta d theta, limit for theta is pi by 12 se pi by 4, pi by 12 se pi by 4, and then integral of d phi, limit 0 se 2 pi. Acha, integral d phi, okay, is phi, upper minus lower limit is 2 pi. Okay, this 2 pi and 2 pi is going to get cancelled. Okay, so I is equal to 400 into 0.8 square upon 2 pi into 0.8 square plus 4. Calculations बाद में करते हैं. Okay, into the integral of d phi, which is going to be phi, upper minus lower limit 2 pi. So I am left with the integral sine square theta. Acha, for integrating sine square theta, let me break it as 1 minus cos 2 theta. 1 minus cos 2 theta divided by 2. Limit pi by 12 say pi by 4. Okay, 2 pi got cancelled. Okay, so current is now equal to, see, let me calculate at least this much part. So this is 55.17. This part is 55.17. Okay, divide by 2 pi kar le agar actually. So even if you take it divide by 2, okay, so let me put that as 27.58. Okay, 27.58. 2 pi ko cancel kiya. Then integral of 1 means d theta integral theta. Okay, minus cos 2 theta integral sin 2 theta divided by 2. Lower limit pi by 12, upper limit pi by 4. Okay, so let me just solve it. 27.58. Okay, 1 by 4 minus 1 by 12 कितना हो जाएगा? Okay, 3 by 12. Okay, 3 minus 1, ये कितना हो गया? I'm just trying to solve this. 1 by 4 minus 1 by 12 will become 3 minus 1 by 12, that is 2 by 12. So 1 by 6, okay, with pi. So first term is going to be pi by 6 minus limits on sin 2 theta. So 45, sin 91, sin pi by 12 into 2. So sin pi by 6, sin 30 degree, half. 1 minus half divided by 2. Okay. So just now final calculations is left. 1 minus half is half. Half by 2, 1 by 4. So I have 7.54. Okay, so the current that is coming up is 7.54 amperes. The current that is coming up is 7.54 amperes. And yes, I think none of the option is matching for it. None of the option is matching for it. Okay, none of the option is matching for it. 7.54. Okay, then of course, if we calculate the total current, then the average current over this particular surface is nothing. The average current over a surface, you calculate it as the current. See, it's clearly evident also, ampere per square meter. The total current divided by the area of that particular surface. And area again we can calculate. Okay, for this given spherical surface, we can calculate the area also. That's not a big deal. Okay, but what is important here is, okay, current is not matching. Current upon that particular area will get the average current also. But we can stop here, none of the option matching. Okay, and it is 7.54. That is the actual value of the current. Okay, because it is integral j dot ds. There is everything right with the calculation as well. Yeah, so 7.54 I can say. Correct? 7.54. Perfect. Let me see if the data is all right. Let me just match the data once. Let me see if the data and all is all okay. Right? Yeah. Okay. All data is correct only. Yes, Dreamer. So it has 7.54. None of the options is matching. Okay. Done. Hai. Chalo. Let's move ahead to the next then. A coil of 300 turns is wound on a non-magnetic core. Okay, having the mean circumference of 300 mm. So it's a solenoidal based question, and the cross sectional area of 300 mm square. The inductance of the coil corresponding to a magnetizing current of 3 ampere. Okay, what is the inductance of the coil? Okay, the inductance is given by what? It is given by mu n square s divided by L. Right, now what is mu? It's a non-magnetic core, so mu will be nothing but mu naught. The n is the number of turns. Okay, so this is going to be n. Okay, and then you have the cross sectional area 300 mm square. This is what I call it as the S, and there is a mean circumference. Okay, there is a mean circumference. Circumference is equal to the length of the mean. It's a circular core. Okay, you can take it as the case of toroid. Okay, so this is the length. This is the length here. Okay, this is the length here. So mu naught n square, n ka value 300, 300 square into S, 300 mm square. So that is for the 300 mm square, 10 power minus 6 divided by the length, and that is 300 mm, 10 power minus 6. Okay, so 300 10 power minus 6 is cancelled. You have 300 square into mu naught. Into mu naught. Mu naught is 4 pi 10 power minus 7 into 300 square. Okay, so this is going to be how much? Let's just calculate. It's a fundamental question. .113. Yes, do I have micro तो नहीं होगा. हाँ, then it will there is some unit mismatch. क्या 300 mm square, that is the surface area. Okay, 300 mm square, perfect. N square divided by circumference of 300 mm, sorry, 300 mm, yeah, that's what. Okay, so there is going to be 10 power minus 3 also left up. Okay, 10 power minus 3. So now it is 0.113 into 10 power minus 3. Okay, that is Henry. Okay, so now it is how much? Multiply by 1000, 133, 10 power minus 6. So 113 microhenry. 113 microhenry B. Approximately B correct. Approximately the B is correct. 113 microhenry, that is the option number B, approximately corrected here. Okay. Yeah. Perfect. Okay. Yes. Good. (16) EC 1 mark. Again a straight question. Faraday's law of electromagnetic induction is mathematically described by which one of the following equations? Is mathematically described by which one of the following equations? Which one of the following equations? Faraday's law of electromagnetic induction. Okay, which clearly proved that in time varying situation, electrostatic field is non-conservative. Del cross E not equal to 0. Del cross E is minus del B by del T. Okay, this is due to the displacement current concept. ये नहीं, option number C. Del cross E is minus del B by del T. Direct question. So you have seen since the beginning, some questions are direct, statement based. Okay, next question. Okay, gate 16 doubly 2 marks. A rotating conductor of 1 meter length. Okay, a rotating conductor of 1 meter length. Okay, is placed in a radially outward. About z-axis. Magnetic flux B of 1 Tesla. Okay, as shown in the figure. Okay, the conductor is parallel to and at 1 meter distance from the z-axis. Okay, it is parallel to z-axis and 1 meter. Okay, it's tracing a circular path around the z-axis. Okay, the speed of the conductor in RPM required to induce a voltage of 1 volt. The B is 1 Tesla. It's a constant field. Okay, but there is a moving conductor. It is based on the concept of, there is a moving conductor in a uniform field, motional EMF. It is based on the concept of motional EMF. It is based on the concept of motional EMF, right? The motional EMF. Okay, and according to it, E, the motional EMF is V cross B. Okay, let's call it as U cross B to avoid the name confusion. It is given by U cross B. It is U cross B. And we need to find the speed of the conductor in RPM. Okay, U cross B. Now have a look into it. Because it is moving in a circular path around the z-axis. Okay, so what is the direction? Okay, at any point. The direction at any point of the circle is given by, whenever a particle is moving in circular motion, at any point the direction is defined by the tangent to the circle. The direction is defined by tangent to the circle. Let's say this is the direction. Okay, but magnetic field, if you look into it, magnetic field is perpendicular to it. Magnetic field is perpendicular to it. Okay, so I can say that what should be U cross B? It can be written as UB sine theta sine 90 because they are perpendicular. It is written as UB. Okay. Acha, also the induced EMF, which is given to be 1 volt, it is given by what? It is given by integral E dot dl. V is integral E dot dl. Okay, E dot dl, and the conductor is placed parallel to z-axis for a length of 1 meter. Okay, let's say this is z equal to 0, this is z equal to 1. We can define this now. Say this is z equal to 0 up to the z equal to 1. Okay, so we can do this integral. Okay, so we can write it as integral EM. Okay, which is going to be constant because it's moving with a constant speed, and B is also uniform here. Okay, and dot dz. Okay, EM dz. Let's put it as EM dz. Okay, and for z equal to 0 to 1. Okay, so induced EMF is nothing but EM into dz integral z 1 minus 0, that is simply equal to EM. Now induced EMF is given. Okay, so that the induced EMF is 1 volt. It is given to be 1 volt. Okay, that means the EM is also 1 volt. Is 1 volt per meter. Okay, uska unit 1 volt per meter hoga, no doubt. Okay, now EM is U into B. Acha, further, how do you calculate U? Okay, the linear velocity, it can be given by omega into R. It can be written as omega into R, from which we can calculate the frequency. Okay, so the EM, which is equal to U into B, is finally 1, or U की जगह रख देंगे omega into R into B equal to 1. Okay, now omega into R, radius is also 1. Look into it. The radius is also 1. The B is also 1. Okay, the B is 1 Tesla, clearly mentioned. So this is equal to 1. Clearly getting that omega is equal to 1 radian per second. 1 radian per second. Okay, F, which is omega by 2 pi. So F is 1 upon 2 pi hertz. But I want the speed in RPM. Okay, what is 1 RPM? RPM is revolution per minute. Okay, yeah, you can always remember by the concept of 60 RPM. See, what is 60 RPM? 60 RPM means 60 revolutions, yeah, 60 rotations per minute. And minute has 60 seconds. That means it has one rotation per second. 60 per 60 second to one rotation per 1 second. Okay, and that is what is 1 hertz. Clear? 60 RPM is equivalent to 1 hertz. Okay, so what is 1 hertz equal to? What is 1 hertz equal to? Okay, what is 1 hertz equal to? 60 RPM, na? In place of hertz, let me write down RPM. 60 RPM. Okay, 60 RPM. So 60 upon 2 pi, that is going to be 30 upon pi. And what is the value for this 30 upon pi? Let me calculate this. 9.55. 9.55 RPM. The answer is 9.55 RPM. 9.55 numerical type question. Let me enter the value here. 9.55. Where is it? Yeah, 9.55 RPM. 9.55 RPM, that's it. Okay. All right. Okay. So before I move ahead, next important update, guys. Yes, if you are again one of them looking for GATE preparation courses, okay, so there are the complete full courses available, 1 year courses, 2 year courses, both the modules available. And if you are looking for a quick revision and preparation of GATE, okay, again in a very systematic manner but in short span of time, so there is the GATE crash course also launched, which ensures your complete revision and preparation in last 4 months. And these courses will offer you live classes, recorded sessions, practice session, mock tests, practice quizzes, okay, and also the practice material, workbooks, PYQs in the printed format delivered to you. Okay, so you can enroll now, available for ECEE and of course for other branches as well. Okay, and learn with your best faculties. To know any particular details about the courses, like how do you get the books, what is the fee structure, what is the timings, when is the syllabus start, complete, etc., any queries, okay, you can contact 924-133-666. I repeat, 924-133-666. Contact and get all your doubts rectified. Okay, now guys, one important thing is, okay, as you know, as in the beginning I told you, I will share you the complete PDF of this particular session with all questions and solutions discussed. And all my PDFs, if you are regular to my sessions, you know, are password protected. Random passwords will be made. So today's password is EMF. Just now we solved a question on EMF, induced voltage. So let's say the password for today's PDF is, randomly I decided, EMF. Okay, let that be EMF. Okay, you will get it in my Telegram group. Also guys, next session for the same PYQ, Monday 9 p.m. And where we are going to discuss again EMT, okay, topics, which is only EC. Okay, yeah, let me specify the topics actually. That is EM waves, transmission lines, waveguides, antenna, optical fibers, and etc. Okay, right. EMT, IISC PYQs for the exclusive EC chapters, that is EM wave propagation, transmission line, waveguides, antenna, optical fibers, and etc. So same time 9 p.m. on Monday we will continue. And similarly, like, you know, we have covered already some subjects. Similarly, all subjects ISC PYQ sessions are going on. You can attend them, okay, continuously and regularly. Guys, if you are filling up the GATE 2024 form, and if you have any queries, like be it 2 paper combination or any eligibility doubts or anything, any of the queries you have, okay, any of the queries you can have. So I'm coming live tomorrow, especially for your doubts. So tomorrow at 6 p.m. okay, regarding to your GATE 2024 application process. Okay, You can ask me anything. Okay, tomorrow at 6 p.m. Saturday, tomorrow at 6 p.m. Okay, you can ask me anything regarding your GATE 2024 application process. Okay, guys. Right. If you have any doubts. Chalo guys, so that's it. Bye bye. And this is the link of my Telegram. As I mentioned, you can join this and be more updated about my sessions and all other updates about exams, notifications, doubt discussions, and etc. Okay, guys. See you the next session. Bye bye. Thank you. Stay safe and do take care of yourself.